Okay, the first thing you're going to do for percent composition is to write the correct formula for the compound. And we are going to use iron 3 oxide today. And so the formula for iron 3 oxide is Fe2O3. And you can do this with any chemical formula, it doesn't matter what it is. Then you're going to figure out how many moles of each type of atom you have. So there are 2 moles of iron and 3 moles of oxygen. And all you have to do is look at the formula to determine this. So just look at the number next to iron. If there's no number next to it, then it means there's just 1. The next thing you're going to do is find the molar mass of each substance in the compound. So there are 2 irons, and each iron weighs 56 grams per mole. There are 3 oxygens, and each oxygen weighs 16 grams per mole. So if you don't already have a calculator out, go ahead and grab one. And when you multiply these two together, you get 48. 2 times 56 is 12. Add those two, and you get 160 grams per mole. Okay, the next thing you're going to do is calculate the fraction you have of each element. Then convert each fraction to a percentage. So we want to find out how much iron we have. And if you look at step 3, you had 112 total grams of iron out of a total of the whole compound of 160 grams per mole. You want to do the same thing with oxygen. So there are 48 grams per mole of oxygen in the whole compound out of 160 grams per mole. Then you're going to convert each one of these to a percentage, and when you do that in your calculator, you'll find that the compound is 70% iron and 30% oxygen. The next thing you're going to do is verify your answer. So add all your percentages together, and they should add up to 100%. Sometimes you'll get something like 99.5% or 101, depending on how you've rounded your molar masses. Sometimes you'll get 99 or 101%, depending on how you've rounded your molar masses. The next thing we're going to do is calculate the percentage of sodium sulfate. So follow the same steps. We're going to break this down into sodium, sulfur, and oxygen. There are 2 sodium atoms, 1 sulfur, 4 oxygens. Sodium has a mass of 23, sulfur has a mass of 32, and oxygen has a mass of 16. So go ahead and multiply these together. You're going to add all these numbers. And you're going to get 142 grams per mole. Then you need to find the percent composition of each of these elements. So, percent of sodium will be 46, which we got from right here, divided by the total, which is 142. Sulfur will be 32 over 142. And oxygen will be 64 over 142. So go ahead and calculate these percentages in your calculator. You might want to pause the video right here. Okay, I got 32%, 23% for sulfur, and 45% for oxygen. And you can tell the oxygen is going to be a higher percentage just by looking at the numbers that you're plugging into the ratio. All right, pause the video right here and see if you can come up with the percent composition of carbon in a molecule of caffeine by yourself. Okay, now we're going to calculate the percent composition of carbon in a molecule of caffeine. And the important thing to know here is I only want you to find carbon. So if you went through and did all the other percentages, that's great practice, but it's also not necessary. So let's split this into its 4 types of atoms: carbon, hydrogen, nitrogen, and oxygen. So carbon has 8, hydrogen has 10, nitrogen has 4, and oxygen has 2. So on your periodic table, you can look up the masses of each of these and go ahead and round those to a whole number, and then multiply each one of these. Now you may be thinking to yourself, I could totally do this on my calculator. Is it really necessary for me to write all of this stuff down? And I would tell you the only thing that you really need to write down is the molar mass you come up with for the compound and each one of your percentages. So the total for this compound, the molar mass, is going to be 194 grams per mole. And we just want to find carbon.
I know, I see you coming the hill.
So carbon's mass is 96 divided by the whole entire mass of the compound, which is 194. And you're going to get 49%. The only thing different on the third problem is that I haven't given you the formula, so you'll have to figure that out on your own. So you've got chromium +3 and nitrate, which is a -1 charge. So this is going to be Cr parentheses NO3 parentheses 3. So let's break this down. Chromium, nitrogen, and oxygen. You have 1 chromium, 3 nitrogens, because this 3 outside the parentheses multiplies by this, and 9 oxygens. Chromium's mass is 52, nitrogen's mass is 14, and oxygen's mass is 16. So multiply all of these together. And then add them up. You should get 238 grams per mole. And then you can go through and do each one of the percentages. So go ahead and pause the video right here and try to do the percentages on your own. For chromium, you'll have 52 over 238. And that'll be 22%. Nitrogen will be 42 over 238, which will be 18%. And then we have 9 oxygens, so that's going to contribute to the majority of our mass in this problem. That's going to add up to 61%. Go ahead and take out your worksheet, and I'm going to go through the first problem with you. So this is not like anything that you saw in your notes, but you can still figure out the percent composition, actually even easier than what you did on your notes. So you've got cerium and iodine, and you want to figure out what the percent composition of this compound is. So all you have to do is add these two masses together, 1.67 and 4.54, to get the total mass. You don't even need to look up anything on the periodic table here. So just add those two together, and you should get 6.21 grams. So the percent of cerium is just 1.67 divided by 6.21, and the percent of iodine is 4.54 divided by 6.21. So go ahead and plug those into your calculator and see what you get. And for cerium, I got, 26.9%. And for iodine, I got 74.7%.